Good evening, good afternoon, good morning. Hello. Welcome to my weekly Node-RED development live stream. An hour or so of working on some corner of Node-RED, doing hopefully something interesting and informative and getting stuff done. Welcome if it's your first time. Welcome back. I see in the chat, Jim, Bob, Noxy Boy. Great to see you guys here already. So what are we up to tonight? Well, what's happened in the last week? We've got the new Node-RED beta released. Node-RED 2.0 beta 2 is out. Along with that, we released an updated version of the Node-RED flow debugger and also a first release of the Node-RED Lint Tool. Now, we haven't actually done a very good job of sharing the news about the Lint Tool, considering it was the first release. So that's something we need to do more on, and actually both that and the debugger create some more docs and resources for people to learn about those tools and how to use them. But something the Lint tool makes use of is a new npm module we created, the flow-parser. So this is an attempt at creating a module that knows how to parse Node-RED flow JSON and gives you some tools for exploring the JSON. So it's what the Lint tool uses. It gets given the flow JSON. It uses the flow parser to parse the JSON and then do its work to run the linter. Hey Zoramel, what's the Lint tool? Is it command line? Okay, let's just take a very quick detour and I can show you the Lint tool. So this is a new, let's get my main screen up. So it's called nrlint, following the footsteps of things like ESLint. And what it gives you, it's both a command line Lint tool, but it's also integrated into the editor. So with that installed, let's see, pretty sure I've got it installed. It gives you a new linter sidebar, and it basically runs a whole bunch of rules against all your flows and generates a bunch of warnings based on your configuration. So these are the rules we have built into it today, but it's all pluggable. So we'll be expanding the list of rules as people suggest them and as we develop them. But things like making sure all your nodes are properly aligned to the grid. If you've got function nodes, you can actually run ESLint. And if you're familiar with ESLint, then you can configure that to lint your code. Anyway, lots of cool stuff. And if you're running it on beta 2, the one we've just released, which adds in a new API in the core, any nodes that have lint errors now get these little exclamation marks in the workspace. Which is quite nice. So you can see things have linting errors. Anyway, so okay, so you have seen it. That's cool. Now, the way the linter works, like I said, is it's given the flow JSON and it passes it to the flow parser library. And the flow parser the flow parser exposes a very simple API. It exposes one function and some types, but a function called parse flow. So you just invoke parse flow with your flow JSON, the flow configuration. I keep saying JSON. Okay, it's not, you don't pass it the JSON, you pass it the parsed JSON. So it is a JavaScript object, you pass it a JavaScript array in this case. and it basically creates a whole bunch of objects. So it creates a flow set, which is the object that represents the complete set of flows. And then the flow set object, you can see it just goes then through, iterates over all the objects in the flow. And if it's a new tab, it creates a flow object. If it's a subflow, it's a subflow object, a group object, subflow instances, flow nodes or configuration nodes. And it works out all the wiring. It deals with link nodes, because one of the useful functions with the flow parser is, once it's parsed, being able to traverse the flow. So link nodes are a way, a built-in, a standard way for flows to connect nodes. So we need to have some awareness of them. And we create what we call virtual wires between nodes using the link node. And so basically it builds this big object representation of the flows. Then amongst the things it then exposes, if I bring the README back up, this is the flow parser. So it gives you the flow set. One of the things it exposes is a function called walk, which so here's an example. We parse the flow, generate the flow, pass it to the flow parser to parse it, and we get our flow object. And then we can call flow.walk. And what that does is it will call the function you provide for every object in the flow. And it calls them in a very well-defined order. So it will first call it for each subflow definition. And for each subflow, it then does the config nodes in that subflow, groups and nodes. Then it does global config nodes. Then it does each flow. And then for each flow, it does the config nodes, groups and nodes. So here's an example where you can, it basically will walk the whole set of flows, and you can test, you get past obj, and you can examine the different type, switch on the type property, which tells you what type of thing it is, flow, subflow, group, config node or node. But what's important to realize is here obj, it's not the raw object that was in the original flow JSON. It's one of the flow parser objects, and they each expose a slightly different API for accessing the properties. Anyway, and the flow set also exposes an export function, which will give you back the flow JSON or the flow object that's suitable for writing back to a file. So it's intended to be, primarily at this point, it's a parser. It was originally conceived of as being more of a manipulation API. So once you've parsed it, it would also expose a bunch of functions for changing things about the flow and then giving you the flow JSON back out at the other end. At the moment, though, its primary use is the parsing and helping you examine the structure of things. So that's the flow parser. And what we're going to do tonight is basically start writing some tests for it, because we've just had a pull request which hadn't merged yet. It's found a bug that shouldn't have been there. The reason it's there is we don't have the test coverage is not where it should be for it. So we do have some tests, but they are crude. So what it does is, whilst I was developing it, I had just two random, reasonably large flows that have a nice representation of things in it in terms of the different types of object, in terms of nested groups, wires, link nodes, that type of stuff. and then the test is, I mean, it was a fairly quick hack together test that just runs on each of those flow JSONs. Not well structured test. There's literally like one test per flow, and it does a whole bunch of stuff. But it reads the flow, parses it, then generates output, or calls the export to get back the generated version of the flow, and then just does a whole bunch of work to verify what went in matches what came out. So did all the nodes, did it generate all the right nodes, does walk, visit, everything, but we don't validate the order, is, for example, an area that needs looking at. And these are pretty crude tests, just checking what went in matches what came out. But there's functionality built into some of these, like I think the node object also exposes things like get sibling nodes, get previous nodes, get next nodes, get downstream nodes, get upstream nodes, get connected nodes, and others, which we've got no tests for whatsoever. So that's what I want to start figuring out, a nice little test framework for this stuff to properly test these, because this is where the pull request we received overnight fixes a bug in some of this. You can see all of these get nodes has this, takes one parameter, follow virtual. So that's what I was mentioning about, like the link nodes, where you create your virtual connection to another link node. So these functions to get the connected nodes, you can choose whether you want that to include the virtual wires of link nodes when considering what's connected to what. So that's what we're going to do tonight. Enough preamble. I think we should just crack on with getting something done. So at least we do have a pretty crude test case there, which we're going to leave in place. Now, just trying to remember how this was very quick and dirty. So when we run the tests, we just run mocker. It's the test runner. So let's go and have a look. Let's go have a look at what the output is. Flow-parser. So if we do npm run test, it runs. It just runs the two tests. But actually, we do the code coverage, which is good. Yes, we do. Ooh. Yeah, so we get code coverage. You can see we're in the green for a lot, but nr node, if we scroll down to see, you can see a lot of red for all those functions I just pointed out. So that's the area we know we need to improve. That's not. I want to refresh this from time to time. And to be frank, this sort of utility library, I want us to get to 100%. Now, we're not going to do that tonight in the next 40 minutes, but at the very least, I would like nr node to get green, get it above. I don't know what the green threshold is, but if you just look at the functions as it exposes at the moment, we only touch 7 of the 18 functions in that file. So let's get that up and see how that works. Okay. Now it is a very crude test setup. We literally just run mocker. Mocker will look for a test directory, and then see in the core Node-RED library we have a bit of our test framework. It still uses Mocha, but it's all sort of, I know how it works, how to add additional tests. I don't instinctively know how to add additional tests when you are just running Mocha bare. So test.js is what they say to run. And there must be the test directory. Here we are. By default, Mocha looks for the glob test star.js. Okay, that's awesome. So so to create some more tests, we can just create them in here. Now, yeah, I'm not going to get too hung up on this now. We're going to call this nrnode.js. I'm just going to copy a lot of this boilerplate code because it's going to be the same deal. And what we're going to do is let's look through the right. So what I'm going to do in a minute is go into Node-RED and create some test flows, some flow JSON as different test cases that we want this code to test, and we'll put that in a file, and then we'll get this test to load that file and do things with it. So let's assume I've got that file already. I don't yet, but let's assume we do. So what we're going to do is we're going to declare a variable flow set for our tests, because what we're going to do is before. So this is something that's going to run in fact, we're going to do it the modern way. This will runs before the tests. So what we're going to do is I think this is all good. In fact, file name, and what we're going to do because I'm going to follow this pattern for other for other things where possible. Let's just sort of parameterize and add constants for things that are going to vary. And when we create our test flow, we'll stick it in a file called test.nrnode.json. And we'll just make this. So we'll read it, we'll parse it, then we'll parse the JSON, and then we'll pass it to the flow parser to generate the flow set. Then, yeah, that's all we need to do. Is that right? What's the complaint? Oh, it's never, that's fine. So then we can say it parses the flow set dot, and now what's the API? Now I will admit I'm coming to this not having touched the flow parser for a couple of weeks. So the flow set itself doesn't export any functions. It's a class which has these properties. So flow set, let's just say then maps. So flows.size should equal 1, because just because we're going to create a flow. We're going to create the flow JSON with just one flow in it. Right, that's basic framework. If we now run Mocha, no, don't reopen that. Go here, npm run test. That fails. In fact, I'm gonna, Mocha -b. I'm gonna skip the code coverage for the time being when we're in this sort of quick fire mode of let's just get the test working. It fails and it cannot read properly. Oh, cannot read properly read file of undefined. That's not the error I was expecting. What have I done wrong there then? Because we want the promises API. Yeah. So how do we access the promises API? Promise example. Oh, and of course they've, there we are. There we are, that's what we want. I'm sure this changed between versions of Node. Is it? And it's, is that the problem? Promises, not promise. Yay, okay. I mean, yes, it still failed, but now it's failed because it can't find that flow.json file, which is absolutely fine because we haven't created it yet. So let's go create that file. So we've got our resources directory, new file, test nr node.json. Cool. And let's just stick an empty array in it. Run the test. Cannot read property equal of undefined. Curious. Oh, that's because npm install. We're going to add the should library. And -d because it's a dev dependency. It's not a runtime dependency. So package.json, yeah, you've got should. So now in here we can do const should require should. And that should now let us write our tests like this. Oh, no, don't run that again. Run this. Yay. All right. So the test is still failing, but now it's failing because it expected 0 to equal 1. So our flows are empty, which is perfectly good because, well, we don't have any flows. So let's go create some flows. No. There we are. Right. I'm going to just call this nr node tests. All right. Let's just start with some simple. It doesn't matter what the nodes are at the moment. What we're going to do is create some very simple test cases, and just to help life, I'm going to name these nodes. How am I going to do this? I'm going to call this flow 1 node 1. This naming scheme is likely to change, but I'll show you why I'm doing it this way in a moment. Okay, if I hit deploy, that's all good. But what we're going to do at this point is if I hit export and say current flow, copy that to the clipboard, then that has given me pretty just fine. So that's given me the flow JSON with the tab with the nodes in. So now when we run the test case passes because it's successfully loaded the flow JSON and it has just this one flow, the one tab in it. Okay, Let's just... All right. Now there is... yeah, that's fine. So what are we going to do next? What we're going to do is let me just think this through. So the nodes are all there by name. What we're going to do is go back to flow set. Nodes, map by name. So at the moment, these nodes have all got their randomly generated IDs, and you can see the name have gone in there. Now that's just convenient because I don't really want to, if I start changing these IDs, I've got to fix them up throughout the file to make sure all the wires work. So let's create a little I mean, one option is I go through and fix the JSON up so that the node IDs are well known. Like I set the node names to be well known. But I think what I'm going to do is I'm going to take advantage of flowset.walk and say if obj.name, I'm going to just create a little map of each object, mapping each object name to the object itself. So that should mean down here we can say node map, we can say should exist node map flow, what did I call it? Flow 1 node 1, flow 1 node 1. Oh no, expected undefined to exist. Okay, that didn't work. Why didn't that work? So after we've run this, what does node map look like? Empty. That's not so good. What have I done wrong in this code? What have I done wrong? Because everything's got a name. So nr object, every nr object. Do I honestly not pull name out? So this is, okay. This is one of those areas where I'm not 100% happy with the API. So it uses the class hierarchy. So at the top level, we have this nr object, which is essentially has all the common properties of any object in a Node-RED flow array. So this is true for groups, subflows, subflow instances, config nodes, the whole lot. They all have these properties, by and large. And then, so they all have, so we pull out of the configuration those values, and then the rest just gets stored in a property called config. And then if we look at node, because it's inheritance, so it's pulled out those common ones by calling the super constructor. We then pull out X and Y, the group ID, width and height if it's there, the label property if it's there, input labels, output labels, icon if it's set, and the others. And then we go through and delete all of them. But name is not one of them, because actually name has never kind of been formed. It's one of those properties that actually if a node doesn't define a name, then that we don't lose sleep over it. It is one of those slightly odd ones that of all those properties, like if I pull up, I don't know, the inject node. Yeah. In its defaults array, where we define the node properties, yeah, unlike all those other properties I've listed, name is one that the node actually has to say whether it has or not. So it's perfectly valid for a node not to have a name. But because of that, the flow parser doesn't treat it as a core property. It means the property will live in the config, which is the node specific configuration, as in specific to that type of node, whether it's an inject node or a link node, or, we don't. Anyway, cool. So now that I've remembered that, the tests are passing again, because we are now successfully building up our map of the node's name, if it exists, to itself. So this is good. So we can now get hold of flow 1, node 1, flow 1, node 2, flow 1, node 3. So what are the functions we actually want to be testing? Let's start with a simple one. Let's get sibling nodes. So these are the nodes that are wired directly to the node we're at. All right, so let's go back to our test case, and we're going to test get sibling nodes. And we're going to say, let's start with flow 1 node 2, the one in the middle, and get sibling nodes. Okay, so this is the node in the middle. It's got a node before it, it's got a node after it. So when we say get sibling nodes, we expect nodes should have length 2, because it's got 2 siblings. Let's just check that's running. Good, that's running. Yeah, get sibling nodes. In fact, let's just... Yeah, let's just run it on the one file. So I always get, philosophically, we're testing this function, but there's a whole bunch of different scenarios we want to test it with. So, do we end up sticking all these tests? Oh, there we are. Yeah. Right. Get sibling nodes. So I change it to a describe, because we're actually going to have a bunch of tests under here. Single node output. Yeah, naming things is hard, so I've got to come up with naming conventions for all of this stuff, but let's not overthink it. Input and output, because it's the node in the middle. This is the node. This is the debug node at the end, so it's single node on input. Cool. So that's I mean, this might seem noddy, and in many ways it is, but you do, as you get a feel for what tests are useful and what aren't, it helps sometimes just to start with the noddy stuff, the simple one-liners. Just build it up bit by bit. So let's now think about what are the other tests for getting sibling nodes that we care about. Now, if we actually look at the implementation, which is a bit of a cheat, this is calling get previous nodes and get next nodes and concatenating them together. So there is something to be said for actually writing more comprehensive tests for get previous nodes and get next nodes, and then slightly more rudimentary tests for get sibling nodes that just verifies that for having proven get previous nodes and get next nodes work, prove that get sibling nodes gives back the union of the both. So yeah, on that basis, I'm going to look at get next nodes next. And likely to come back and rework the get sibling nodes tests. So I'm just going to copy what we've done so far. And this is get next nodes. So single node on single output. That's good. Now obviously these other tests don't apply because, well, I mean, let's see what we get. So for the first two nodes, get next nodes should return 1 because they're each wired to 1, and for the third node, its output isn't wired to anything, so it should have a length 0. Cool. But again, not so interesting. I think there is going to be some interesting cases around, let's right, oops. I'm getting the linting errors, but let's get rid of the linting errors. I don't like the exclamation mark, and I think it's aligned to grid is complaining. Yeah. So we're going to call these flow2. But this time on the function node, we are going to add a couple of outputs. And we're going to, just for variety, add a node to, well, let's add in a couple of nodes. Nope, don't call it that. Okay, so here's a flow that has multiple nodes connected to one output, an output with nothing, and an output with, well, not the first output with something connected. So again, let's export that flow JSON and update our file. And then go back to our test cases. So what we really care about here is flow2 node 2 now. Flow2 node 2. And of course, well, I've not actually done any verification of what they're connected to. So I should be verifying that as well. So, but this node is connected to 3 nodes. And so it's single node, multiple nodes. on multiple outputs, because it's outputs we're caring about now. This one was no node on output. That is a test case that's not interesting for next nodes. It's just one node wired to the next, so I'll get rid of that. Yeah, 0, 1, and many. That's a nice collection of tests. And the tests continue to run clean. But let's just do what's the code to verify it. So if we've got here, we know that we've got one element in here, node 0, and we know it's should equal flow 1, node 1 was wired to node 2. So, and then down here, now this is a bit trickier because it's returned an array of 3. Can we assume the order? Can we assume what order they're in? Now, I suspect we can probably get away with assuming the first node it's connected to is node 3, then 4, then 5 in that order. So why don't we just run with that and see, does that match our... Yep, so tests continue to pass. Okay, so that's working. Yeah, that is working. And what we're going to... No, I won't copy and paste that yet. There's another case I want... another case we need to include, which is the link node. So let's create a link out node and a link in node. We'll connect them together and put a debug here. So now the question is, what are all these linting errors about? Link node has no name. Well, we're about to fix that. So this is flow 3 node 1. Flow 3, for variety, I'm going to call this link 1. I think it'll probably help in the test to, if we see the fact it's called link, we'll Yep, I think that's being all pretty consistent in our naming of things. Okay, so let's export, update our test flow. So, we've got a couple of tests to consider. First is no node on link on, so that's a link out node. Yeah, no node on link out output, as in this link node hasn't got an output, it's got nothing wired to it using a regular link. Okay, so that's what we care about here. So this is what flow 3 link 1 is, the node we are interested in. Flow 3 link 1, get next nodes should have length 0. Virtual link to node on link out output. Ooh, not viral, virtual. So this is where, in all of those APIs, we have this follow virtual flag. So let's go, and if I stick a true in there, then we now expect the node array to have our link node. Config.name should equal flow3 link 2, because that's the link node we're wired to. And we get the test fails. So let's just double check it's a good test. So we're saying go and find flow3 link 1, which is this node here, flow3 link 1. It says give me your next nodes, follow virtual links. Well, this node has definitely got a virtual link to this link node. So we expect to get an array of 1, and that one should be flow3 link 2. But that test is failing. And this is where I almost couldn't have planned it better. Com node-red flow parser. This is where this pull request comes in. Fix failure in gathering link node information. So this slightly changes how it identifies the link nodes. So this is PR number 1. So what I'm going to do in here is do git PR1. So this little git script I've got goes and grabs that pull request. So I'm now in that pull request. So let's now run our tests. And the test passes. So that tells us this is a good fix, because it's fixed our test. Let me just see what was happening. Let me switch to the code to show you what this bug was. It's a very subtle bug, and well done to Nishiyama-san, who'd not really seen this code before, for finding it. Yes, we were in here where we create the new sorry, I'm just okay. Got slightly confused because I was I forgot I've still got his PR checked out. So let's do git PR done. So this is taking us back to what the code is in my without his fix. So this just iterates over all the objects and decides what type of object do I need to create. And we're at this point, we've created a new NR node. It's a node in a flow. And then it was looking at config.type, saying, is it a link in or a link out? If so, add it to our list of link nodes. The problem is this constructor NR node config is destructive to the object you pass in, which is kind of intentional. We do a fast JSON stringify JSON parse clone of it. So we're not modifying what the external caller of the function has provided. We are modifying our own internal copy of it. But the point being, when you call the NR node constructor, which in turn goes into NR object, we go and we delete config.type because we've copied the type onto the node object itself. So that means when it comes to do this test, well, config.type no longer exists. It's been moved to be a property of this object. So this is where the fix from Nishiyama-san is good, because what it does is, there's a couple ways he could have done it. He constructs the node object and adds it to the set of nodes. And then he looks at the type which he stored up here. Now, technically, he could do node.type because this type value has been copied onto the type property of this object. So you could actually do this without these two properties, because this would be node.id and node.type. So yeah, I think for the sake of getting this in, let's merge that. Let's pull it down. What are you merging the branch? What have I got locally that I haven't pushed? What have I done locally? I've updated my gitignore file. Okay. I'm not going to lose sleep. Right. But let's just check our tests still pass, having merged that down. I think because I'm keen, I'm also keen for this code to be as efficient as possible and clean. I'm just going to slightly rework his fix the way I would do it. Just a bit more succinct, fewer local variables. Which I can safely do that refactoring because we have a test case that requires that code to be working. Awesome. Okay. So we've done all that. Let's describe is it previous nodes? Get next nodes, get previous nodes. So get previous nodes. If you remember flow1 node 1, flow1. We now do the reverse of all those test cases. So work backwards along flow1. Let's just replace all these calls to next node to previous nodes, because that's going to definitely trip me up in a minute if I didn't do that. So single node on single. Get rid of the phrase single input, because in Node-RED you only get the one input. But it is now flow1 node 3. This node, which we want to work back from, should have length 1, and it's connected to that's still true. 3 is connected back to 2. So no node on output. So this is the inject node. So flow node 1 this time should have no previous nodes. No node on input. Multiple nodes. Okay. We don't have multiple inputs, but we do need a test case for multiple nodes connected just to the one input. So this is where the naming scheme I already regret. I'm not going to rename all these and fix the test case. We're going to add node 6 over here. So now we've got a test case for 2 nodes connected to the input. Update our flow JSON. Oh, no, I just exported the node. Export the whole flow. That would confuse me as well if I... Right. Keyboard trouble. Export. Copy to clipboard. In here. Paste. Done. Okay. So, multiple nodes on input. And it is still flow to node 2 we care about. But it's going to have, should have 2 nodes connected. And it'll be node 1 and node 6. And the nodes we should find there. Then, I've got to be consistent in my line breaks. So no node on link in input. So now it's flow 3 link 2. Flow 3 link 2 should have no previous nodes. Virtual link to node, virtual link from node on link in input. So it's flow 3 link 2 we care about, and that should be connected to flow 3 link 1. Flow 3 link 1. Right, this should just pass. It does. Awesome. So I think that's covered a bunch of useful test cases. The only other one, so if we come back up, in fact, I'm going to move the sibling node tests to below the previous and next. And we will just want to add in flow to node 2 as an interesting case to get both siblings, because there's lots of them. And we also want the link node cases as well to make sure the virtual property gets passed through properly. So multiple nodes on inputs and outputs. So flow to node 2 get sibling nodes should have length 5. We've got 5 nodes connected. And now this is where the order might get a bit funky. I'm going to take a stab at, I think the order, I predict the order will be 1, 6, 3, 4, 5. Shouldn't really, I mean, yeah, we shouldn't. Well, the test is passing, so I've got the order right. Let's just comment those two out because they're not doing anything yet. Just to show you, if I were to, let's say I swapped, I don't know, 6 and 3. So it's still testing the same set of nodes, just in different order. The test fails because the order was wrong. Now, like I said, it might be nicer yeah, it would be cleaner to, having been given this array, convert the array to a map of some sort and then validate that we've got all the entries in the map we think we should. So it doesn't, we don't care about order, but should we do that? Should we do that? Right, let's do that. It's just, I'm just trying to be correct with this stuff. So we're going to define a function, convert node to node array to map. Create our result object. Do nodes for each. And we're going to say result n dot. And of course we need to map it by name. So n.config.name doesn't really matter what we set it to because I don't think we're going to be looking it up ever. And then function validate node list nodes. No, can't call it map. I want to call it node map, but I've already used node map in this file. Validate node list expected nodes, and what we'll do is say so node list is going to be one of this. Right, let's call this convert node array to node list. Is that helpful? No. Keep that as map. Node list will be one of those map objects. So we can say first up object dot keys node count is that dot length. Say expected nodes. Got to get this the right way around. Count should equal expected nodes dot length. And expected nodes, this is going to be an array of node names we expect for for I equal naught, I less than node count. Node list should have property expected nodes I. Okay, so this will, given one of these maps of an object which has all the node names as keys, we're going to pass it that plus an array of the names we expect. This will basically validate everything in that array exists as a key in that object, and by validating the length we make sure there's no superfluous ones, we've got the right number. So that means we don't have to care about order anywhere, which means what we're gonna do is for each of these we're going to validate node list of convert node array to map of nodes, and this one we expect just to have flow1 node 2. This one we expect to be an empty array. This one we expect to have these 3. Another empty array. Another go to that as well. This is flow1 node 2. Anyway, I hope this is interesting. We're going to wrap up in a minute once I've got this updated. Yeah, this is the flow parsers. We don't use it in the core of the runtime. There is part of me that thinks that's one of my personal goals for this flow parser module is to be something that then the core starts to use as well. So we have a single standard library for parsing flows. I think that's actually quite important to have a standard utility that others can then start using. Who, maybe they want to be able to generate correct flow JSON. Maybe in the future we have what's going on here? Yeah. Sorry, I've just reached. So flow 1 node 1 get sibling nodes. That should be connected to flow 1 node 2. Flow node 2 sibling nodes should be node 1 and flow 1 node 3. What was I saying? It may well be we have a new flow file format at some point. And so having a standard library for doing the parsing that can handle all the different formats, when I say all, if we were to get a new format, we would have 2, then I think it would be worthwhile having a standard library that, again, then other people who are trying to do things with flow.json would be able to make use of in what they do. Okay, I think I'm almost there. Of course, I've done all of that refactoring without running the tests once. Let's run them. No. Okay. Okay, that went boom. Went boom rather spectacularly. What have I done wrong? Unfortunately, it's gone spectacularly so wrong. My scroll buffer doesn't actually take me to the top of the error. Right. What have we said? Node list. What's not helping is, let's just map, because we don't need, all this output is because the result map was from the name to the full node object. Well, I don't need the full node object. I just need to know if it exists or not. So if I, that really annoying Z shell issue. Sometimes when you hit Control C, it just kills the window rather than, anyway. Let me get back to where we were. And it is 9:10 here, so we aren't going to run much longer. Right, here we are. Is this just a genuine... Yeah, I think this is just a genuine typo in the test rather than a bug in the test, if that makes sense. We are in line 114 here. Flow 1 node 2 get sibling nodes. Yeah, we expect sibling nodes of flow 1 node 1. Flow 2 node 3. Where's that come from? That should be flow 1 node 3. Cool. Okay. Yeah, just a little typo as I was copying over the copying over all the node names. Oh, what was that notification? No, don't worry about that. Cool. What have we got? We've got all the tests passing. All right. So let's do that little test where I reordered. Let's just put all these in numerical order. And then let's rerun the test, which failed last time because the test, there we are, the test passes. So that's good, because we don't make any statement as to what order. Well, I don't think we make any statement as to what order the array that is returned. Yeah, the order shouldn't have any significance. So let's just finish it off for completeness. and sort out sibling nodes with link nodes. So get sibling nodes of flow3 link 2. Let's go find what flow3 link 2 is. So sibling nodes of that without following virtual should just give us flow3 node 2. So that should just be, what I say, flow3 node 2. But then if I call it with true, then it should reach across here and it should also return flow3 link 1. So let's copy that. Okay, let's run. Cool, and that's passing. Well, that's worked in one direction. Let's make sure, because technically that's only validated that we've passed this true flag to the get previous node call on the in the internals. So so let's do link in. Just get this naming button. No virtual. Linking some things with virtual. So copy those two, and now we're going to do link out siblings, link out siblings. So flow3 link 1 is our link out node, and without virtual, you'll go to flow3 node 1, flow3 node 1. Link 1, go with virtual, go to link 2, and I think that hits every combination. Awesome. Okay, I'm going to leave it there in terms of writing tests. I think we've pretty thoroughly tested get sibling nodes, get previous nodes, get next nodes, get downstream, upstream, and connected has a whole bunch more. So that's upstream and downstream is, say, let's go find have I got must have an interesting flow. No, I don't. Like if I was on this inject node and I said get downstream nodes, it should return everything here. And again, with a follow virtual flag, so should it follow the links? And you've got to deal with what happens if there are loops, and we need to add tests for loops and a whole bunch of other stuff. But it's 9:20. I think that's good for now. What I'm going to do though is just make sure all of our tests still run. Awesome. We are going to I want to get into the habit of... do I want to get into the habit? No, ignore that. What we're going to do is just commit to these changes, and I think the only change here is we've added mocker and should. Oop, sorry. Oh, come on. What's happened? Oh yes, I added a syntax error. That's more for the linter than anything here. Yeah, I'm going to revert that because I don't want to confuse matters. But we do need to add in our new test resources. So, add unit tests for nr node get next previous sibling nodes. Commit it, wait for my git commit to return because it takes so long. Git push. Awesome. So now if we just jump back to flow-parser, let's go look at our actions. You can see the unit tests are already running. Let's see what they do. On node 12, which should just work. Run tests, level passed. We haven't published to coveralls because I think we only published coveralls on this one. For node 14. Awesome. In fact, that's something we didn't do locally. So let's do nyc mocker. npm run test. nyc is the code coverage. Let's right. So this, I haven't refreshed this. This is from before. You can see overall 80, 64, 70. You know what? Rather than try and do a one time, let's do. Let's reload it. So if I just compare these two tabs, so this was before, this is after, and seemingly nothing has changed. That's slightly dispiriting not to have seen any change. No, there's definitely change. Look, 62. So, am I looking at, oh, I know what. I bet our default NYC configuration is not generating the HTML reports. Okay, 62%. That's good. If I go to coveralls.io, Node-RED, flow-parser. Nope. Oh, no, I'm not doing that now. Oh, that's why, because I haven't actually authorized it for that repo. And I'm not going to do that on the live stream. Let's have a look. Build 14, run tests. Yeah, this isn't how you meant to do it, but from the tests we have just committed, that's our stats. If I go back to Nishiyama-san's pull request as just a convenient point in time, I want to see is that going to work? Here we are. So here's the coveralls report. So before we were at 80%, we're now up to 83.98%. Changed. We've increased our coverage on NR node. Coverage fell on NR flow set. Oh, that's, yeah, okay. Yeah. Anyway, I'm not going to waste your time, but it's gone up. We've increased our code coverage by 4.8%. Awesome. Plenty still to do, but that'll do for tonight. Yeah. So I hope that was interesting. If you're interested in writing tests for this stuff, just shout. Like I said, I want to get pretty solid test coverage on this because I do see this being a really useful utility. Things like generating diffs of flows. There's a bunch of code in the core that does that. That's that's the sort of functionality we'll add to this library. So given two flow JSONs, give a summary as to what's changed, but in a way it's not just a diff of JSON, it's an actual diff of contextual diff of what's changed in which flow, and recognizing a change is just a node has been moved, so its X and Y coordinates have changed, but no function has changed, for example. Cosmetic changes versus functional changes. That's one of the benefits of having our own diff tool rather than just doing raw JSON diffing, which is not fun for anyone. Cool. I did push that, didn't I? Yes. Awesome. Right, I'm going to leave it there, go and have a cup of tea. Thanks for joining, everyone. I hope that was interesting. More of the same, I think, next Monday. Yep, more of the same next Monday. I will say now, we won't be in 2 weeks' time, as it is my wife's birthday, so I will not be sitting in front of the computer in the evening. Yeah, seems fair. Have a good week all, stay safe, and see you next time. Cheers. Bye.